Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Darwisyah hizam and I'm currently studying in IITM Tapa. I'm taking course of Diploma in Science, which I'm a student from Faculty of Applied Science. First of all, this video is for my individual task for the subject of General Chemistry, which the code is CHM131. I'm from Group 7. So in this video, we will learn about the topic of quantum mechanics that we will learn also in Chapter 2. So first, in this topic, we're gonna learn about quantum atomic model, principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. This topic is not too hard, but once you understand it, it will make you easier to learn the whole chapter. Okay, let's start with quantum atomic model. First of all, the quantum atomic model we use is Bohr atomic model. This model explains that in an atom, the electrons that are negatively charged will revolve around the positively charged nucleus in a definite circular path called orbits or shells. So in each orbit or shells has a fixed energy, and the circular orbits are known as orbital shells. So in this each orbital shells has its own energy. So the energy levels are represented by an integer that also we will learn later, such as n equal to 1, 2, 3 or more, and also known as the quantum number. Other than that, the electrons in an atom also can move from a lower energy level to a higher energy level by gaining the required energy, or an electron also can move from the higher energy level to a lower energy level by losing energy. For example, in the flame test experiment, when it's being burned, the atom will move from the lower energy level to its highest energy level when it's on the excited state, but not long from that, it will return back to its normal state, which is the lowest energy level. Okay, next, did you know that these are the wave function of each electron and described as a set of 4 quantum numbers, and this set describes the distribution of electrons in an atom, which means all of this in the set is function for the electrons in an atom. Okay, first, principal quantum number. Second, azimuthal or angular quantum number. Third, magnetic quantum number, and the last one is spin quantum number. So first, quantum number have 4 sets. So the principal quantum number, the symbol is n, describe the energy level of the electron in an atom. So the second is azimuthal or angular momentum, which the symbol is L, describe the shape of orbital. And the third one is magnetic quantum number, which the symbol is ML, describe the orbital orientation in space. And the last one is electron spin, which the symbol is MS, that describe the direction that the electron spins, whether it is clockwise or anti-clockwise. Okay, first of all, let's start with principal quantum number. So the principal quantum number, the symbol is N, and describes as shell or energy level. So the values is positive integer, which is like 1, 2, 3, 4, and more, or using the code letter, which is K, L, M, or N. For example, n equal to 1, which is the first shell, or we can use K as the shell that closest to the nucleus that have lowest energy. And another example, n equal to 4, or N, which is the fourth shell, have the highest energy. As a conclusion, the higher value of n, the higher is the energy of the shell, and the bigger size of the electron orbital, which means when the n is increased, which means the shell is also increased. So if it has n equal to 4, it has 4 shells. So the size of the electron orbital is much more bigger because it has many shells. As the table shown, that if the number of shells is 1, which is n equal to 1, the name of it is K, and 2 is L, 3 is M, and 4 is N. So next, to make our understanding much better, as shown in this picture, at the middle one, the red one is the nucleus, and if n equal to 1 is the first shell, n equal to 2 second shell, n equal to 3 is third shell, and n equal to 4 is fourth shell. So the n indicates the atomic size. So the higher value of n, so the bigger the size of the atom. So distance between nucleus and electrons also will increase. So the attraction between nucleus and electrons will be decreased. So this means that when the attraction is decreased, so the energy to attract it will be much increased because the atom much bigger, so it is much energy required. Next, we will continue with the azimuthal or angular quantum number, which the symbol used is L, and it described as a subshell in an atom. So the values of integers from 0 to n equal to 1, which is n equal to 1, n minus n, like that. So as an example, if n equal to 1, 1 minus 1. So the subshell have 1 because n have 1. So the subshell is 0. When n equal to 2, we have 2 subshell, which is 2 minus 2 and 2 minus 1, which the subshell is 0 and 1. And for the n equal to 3, we have 3 subshell because it's on the third shell. So we have 3 minus 3, 3 minus 2, and 3 minus 1, which is 0, 1, and 2. So this subshell depends on the value of n. Like I said before, if the first shell, so we have 1 subshell. If the second shell, we have 2 subshell, 0 and 1. So the values of L are related to names or orbitals or letter codes for subshells, such as the table shown that the value of L is 0, the orbital name or the subshell letter code is S. If 1, B, 2 is T, 3 is F, and 4 is G. For example, the subshell with n equal to 3, which is in the third shell, and L equal to 1, which is the second subshell, because third shell have 3 subshells, so 0, 1, 2. So L equal to 1 is the second subshell. So when L value is 1, so the orbital name is P, so it became the 3p orbital. So L also can tell us the shape of the orbital. So if S, the shape is sphere, P shape is dumbbell, and D shape is double dumbbell as shown in these pictures. So to make it more clear, as shown in this illustration, the middle one is nucleus. So it has, in an atom, we have shell and subshell. For an example, n equal to 1, which is the first shell, have 1 subshell, which is S. And then n equal to 2 is the second shell. It has 2 subshell, which is S and P. So for the third shell, which is n equal to 3, have 3 subshell, which is S, P, and D. And for the fourth shell, n equal to 4 has 4 subshells, which is S, P, D, and F. Okay, next, we continue with magnetic quantum number. So this magnetic quantum number symbol is ML. So it describes the orientation of orbitals. The values start from negative L, 0 to positive L. For example, if L equal to 1, so the magnetic quantum number is negative 1, 0, and positive 1. So if L equal to 2, negative 2, negative 1, 0, positive 1, and positive 2. So as it's shown in the pictures, for example, in p orbitals, is also represented by the subscript of px, py, and pz, which the orientation of the orbitals. So one orbital can only fit with 2 electrons only. For example, as shown in this table, the n equal to 1, the first shell, it has only 1 subshell. So the value of the subshell start from 0. So name of the subshells, 0 represents the S. So name of subshells is 1s. So the orbital value is 0 because it starts from 0. So the total orbital only 1 because it has only 0. So the maximum electron can fit in one orbital is 2. So the total electrons is 2. So next, if the n equal to 2, which is shells number 2, the second shells, it has 2 subshells. So the value of subshells will be 0 and 1. So the name of subshells, 0 represent the S, 1 represent the P. So 2S and 2P. So are the orbital value 0, and for the 1 it starts from negative, right? So negative 1, 0, and positive 1. So the total orbital of the first, it has 1 orbital, so it can fit 2 electrons. So the second one is 3 total orbital because negative 1 is 1, 0 is 1, and positive 1 is 1. So we have 3 total orbital. So in 3 total orbital, we can fit 2 electrons in each orbital. So 2, 2, and 2. So we have 6 maximum electrons in the orbital. So total electrons in the second shell is 8. For the third shell, which is n equal to 3, it has 3 subshells, 0, 1, and 2. So as we learned, 3s, 3p, and 3d. So 0 is the first subshell in the orbital value. So the 3p has negative 1, 0, and 1, which has 3 orbital, and 3d start from 2. So negative 2, negative 1, 0, positive 1, and positive 2. So it has 5. So 5 orbital can fit 2 electrons, which is 10 total electrons can fit in. So total electrons that can fit in the third shell is 18. Last but not least, the spin quantum number, the symbol used is S. So it describes the direction in which the electron spins on its axis. Spin quantum numbers have only 2 values, which is the first one is positive half, which explains the electron spins in clockwise direction, which follows of the arrow of the clockwise. So the second one is negative half, which explains that the electron spins in anti-clockwise, which against the direction of the clockwise. So only 2 electrons may occupy each one orbital orientation, and the electrons must have opposite spin. That's all from me. I hope you understand my explanation. Thank you for taking the video. Thank you for watching this video. Thank you for hearing me. So that's all from me. Thank you.